Hey guys, so you've seen these notes before. I'm just going to review some things and add some things. So you should watch this video anyways. You might see some stuff you didn't see before. Okay, so this is chapter 2, lesson 1, decimals and fractions. The first goal is to write decimals as fractions and mixed numbers. And goal number 2 is to go the other way around, write fractions and mixed numbers as decimals. Alright, the whole point of this chapter, at the end of it, you should be able to tell or know which is better to use. Because there'll be time to use fractions, there'll be a time to use decimals or percents. You'll have to figure out which is the best time. Okay. I just wrote this up really fast. You should have this already in front of you. We talked about what a fraction looks like, and I said there's 3 kinds of fractions to really consider. A proper fraction, where you have a numerator and denominator, where the numerator is smaller than the denominator. By definition, that's a fraction, it's part of a whole. Its value is less than 1. So, by definition, any fraction that's proper is less than 1. Okay? An improper fraction has a numerator that's larger than the denominator. That means you have more than 1. So, for example, 3 over 1, you're making sets of 1. You have 3 of those. That means you have 3. That's a whole number. And that's more than 1. So, while there's nothing wrong with an improper fraction, it still gives you information you need to make visuals and whatnot. It kind of goes against the definition of fractions. Okay? Again, fraction is a part of a whole. An improper fraction is not part of a whole. That's actually you have more than a whole. Okay? A mixed number is what happens when you convert an improper fraction back to a proper fraction. But now you're going to have a whole number. Okay? A whole number and a fraction. That's all it is. A mixed number, literally, you're mixing up a whole number and a fraction. Okay? All right. A percent. What makes a percent a percent? The symbol. The percent symbol. The percent symbol. If you don't see a percent symbol, it's either going to be a whole number, a decimal number, or a fraction, or something like that. But here's the thing, especially with these two. Right here, these two that I'm looking at right now. If you add a percent to a decimal number, the rules change a little bit. Because when you convert percentages to decimal numbers, you're going to have to move the decimal point. You can't just leave it like this and say, oh, it's 32.6, for this example anyways. And same with a fraction. It might have a fraction in front of it, but it's still percent, and the rules for percent still apply. Okay? Decimals are a little easier to explain. Basically, if you see that little dot, it's a decimal point, and that indicates you have 2 things going on. You have a whole and a part. Okay? And how do you say it? Again, you could say 1.2, but it'd be more correct to say 1 and then how many parts you actually have. In this case, it's 2 out of 10, 2/10, 1 and 2/10. Okay. Let's continue. For this lesson, there is only one vocabulary word that you have to think of, or you have to know, and that's rational number. Okay, so what's a rational number? It's any number that can be written as a fraction, and that's pretty much it. Okay? So, for example, 0.3 can be written as 3/10. Okay, that's rational. 4, a whole number, can be written as 4 over 1. It's a fraction, so it's rational. Again, I like to tell people, think of the word rational. It has the word ratio in it, right? And if you remember what ratios are, basically they look like fractions. Fractions? Fractions. Ratios look like fractions. Okay. All right, so we're going to get started then on the got it. All right. Again, our first goal here, goal number 1, is to change decimals to fractions and mixed numbers. Okay? That's our goal. Now, to help you out with that, you're going to need to copy one thing out first, okay? Now, I'm just trying to find something I made earlier, but I think I lost it. That's okay. You know what? It is what it is. Let me just say this then. You have to know one idea. It all starts with a little dot. And what I'm doing here, I'm kind of making it like a wall. This is obviously your decimal point. So it all starts there. Okay? And then going to the right, we have 1/10. 1/100ths, 1/1000ths, and so forth and so on. 1/10,000ths. Okay? What's going on is the value gets smaller. Okay? You're actually dividing by 10 as you go to the right. This is all a base 10 system. It's based on the idea of 9 digits, being able to write actually 10 digits, and with those 10 digits you can write any number you want, starting from 0 all the way to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's like the alphabet. With 26 letters you can write any word in the English language. Same thing. Our math system is based on the idea of 10, base 10. Okay? On this side, same idea. Ones, 10, 100, 1,000. Okay? But in this case, in this direction, from 1 to 10, excuse me, that looks a little weird. From 1 to 10, you're multiplying by 10. You're multiplying by 10. You're multiplying by 10. Okay? So, I'm going to write the words. This is the ones. This is the tens. I was going to write tenths. Can you believe that? And this is the hundreds. And since I went all the way to thousands, let me add that too. You really can't see it, but there it is. Thousands. Ones, tens, thousands. 1/10, 100, thousands. I want you to notice that it ends in an S. On this side, all of them end with an S. Okay? This would be the whole number side. It ends with that S. That means it's a whole number. Okay. On this side, you have the tenths. I'm not trying to be funny when I say it with a lisp, but really that's how you say it. 100th, thousandth. All right. And if you notice, it ends with a THS, THS, THS. This would be the parts of a whole. The parts of a whole. Okay? And it ends with a THS. All right? There's a lot of information in this little drawing I made. Now, obviously, you can go forever to the left, forever to the right. You just keep going by multiples of 10, or powers of 10, excuse me. 1,000, 10,000. Add a 0, 100,000. Add a 0, a million, and so forth. But it'll be millionth, 10 millionth, 100 millionth, and I'll keep saying that part, okay? You're just getting a smaller and smaller value, okay? So if you go from 1,000 to thousandths, you've definitely lowered the value. You're going lower. You're dividing by 10, going in this direction. If you go this way, your value is getting larger and larger. You're multiplying by 10. Multiplying by 10, multiplying by 10. All right? So just in this direction, smaller value. In this direction, larger value. All right. Let's actually do some problems then, and I can show you what's going on. All right, these are the got it's. Pages 90 to 92. We're going to do A through G. All right. So here's the deal. You have letter A. You have 0.8. You got to change that 0.8 to a fraction. All right. What do you do? All right. You're going to write the denominator. Everything to the right of the decimal point becomes a denominator for this fraction. Okay? So literally, write the denominator. Write the denominator. All right. So I have my 8. Right. Add a fraction bar. Yeah, that line that goes under it is called the fraction bar. Okay, add a fraction bar. So now I have 8. There's my fraction bar. Now, I realize some of you don't like all this drawing. Add a fraction bar. There's my fraction bar. What's the last step? Count the place values. All right, back to this. Start at the decimal point, count the place values. 1. Now, if you look at the chart you made, 1. Oh, it's a tenth. The denominator is going to be 10. 8, 10. Okay, now there is one final step. Final step. Simplify. If it's possible. Because sometimes it won't be possible. You just have to leave it as is. Okay. 8 tenths. They're both even numbers. I can divide by 2. 4/5. That's your final answer. So, 8 tenths is equivalent to 4/5. That's your answer, 4/5. All right. Now, I realized I took a lot of steps. I kept adding, do this, do this, do this. Eventually, you will get the hang of it, and it won't be such an issue. Let me highlight this so you know it's still. I'm going to do one more. All right. 0.38. Or 0 and 38 hundredths. Now, how do I know that? Counting the place values. Look, without going back to the list, tens or tenths, hundredths, right? Just keep adding a 0. Add a 1 to that. Add a 0 to the 1. It's tenths. Add a 0 to the tenths, hundredths. But more on that later. Okay, the first thing I said was, okay, this becomes a denominator. There's my denominator. Add a fraction bar. Okay, count the place values. Decimal point, tenths, hundredths, or 1, 2. And if you look at the chart again, you know what, I'm going to do it just so you can see I'm not getting to you. I'm not blind or anything like that. 2 place values, right? Decimal point, 1, 2. Oh, it's a hundredths. The denominator is going to be 100. And again, simplify if possible. All right. Oh, you know what? I said it was 38. Why did I say it was 38? My glasses. I think I need new glasses. Guys, I apologize. Don't get old, guys. Stay young forever. Okay, no harm done. Easily fixed. I'm glad I caught it. All right. You divide by 4. Divide by 4. 7/25. Now, how do I know this? Again, just times tables, guys. Seriously. Times tables. You really got to know your times tables. All right, letter C. We have 0.125. All right, I'm going to shorten it just a little bit. I think some of you guys are starting to get the pattern. Okay. This is the denominator. Sorry, this is the numerator. Excuse me. I don't know if I said the other problem, but basically that becomes the top number. This is the numerator, 125. Here's my fraction bar. I count the place values. Decimal point. Tenths, hundredths, thousandths. Okay. I can definitely simplify this. All right. I can divide by 25. That's not the greatest common factor, by the way, but it's something. Now, how do I know it's 125 or 25? Again, I'm thinking of money. $1.25, $10. You definitely divide dollars by quarters, right? So 25. It gives me 5. And this would be, I believe, I want to say 440. Yep, 40. Okay. I divide by 5 because I can simplify that. And I have 1/8. Guys, it really is that simple. Now, of course, the question could be, what about if you have a whole number? What happens to the whole number? Well, okay, I'll give you another example right now with the whole number. It's nothing to panic about. You can do this. What if you have a whole number? And that's a valid question. What if I give you 9 point, I don't know, let's make this up, 9.75. Okay, now here's the beauty of it. You don't have to do anything with the whole number. The whole number stays as is. You're definitely going to have in the answer 9. I want to make a prediction. 9 and some fraction. Okay? Some fraction. We don't know what it is, but I'm predicting you're going to have a fraction. So you change this into a fraction. All right. I hope you don't get confused again with what I just did. I'm going to go really fast on this because I think you guys get it. 9 and 75. There is my numerator. What's the denominator? There's my decimal point. Tenths, hundredths. Okay, I can definitely divide this by 25. It's like quarters. All right. My final fraction then is 9 3/4. That's all it is. Don't worry about the whole number. You just move it over, transfer it over, and you're fine. You don't do anything with it. It's just basically, boop, move it to the side, put it aside, just worry about the fraction. It's only the fraction you're changing into a fraction. Wait, did I just say fraction? It's only the decimal part that you're changing into a fraction, okay? It's late. Okay. All right, we're done with A, B, and C. Let's look at D. Okay, we have a word problem. It takes approximately 4.65 hundredths or 4.65 quarts of milk to make a pound of cheese. Express this amount as a mixed number in simplest form. Now, I know the answer is there. That's okay. But what matters is how you get there. And it doesn't tell you how to get there, so let's go ahead and do this. All right, letter D. And it tells us we have 4.65. Okay, we got to change that to a fraction. Now, like I said earlier, the whole number just goes on a little trip. You don't have to do anything with it. Just leave it alone. It just moves over here somewhere. Okay, 4. And the decimal point becomes the word and. 4 point or 4 and. Now we just got to worry about this part. We got to change the decimal number to a fraction. All right, 65. There's decimal point. Tenths, hundredths. All right, so 65 hundredths. Okay, now guys, you realize I kind of started a little bit because I kind of want to go through this fast, and you'll get that to that point too. But I have to slow myself down because I don't want to make a mistake. All right, they end in a 5 and it ends in a 0. That means I can use 5 as a factor. I can divide by 5 or make groups of 5 out of that. Okay, 5 times 13 gives me 65. 5 times 20 gives me 100. Okay, so 5 and 1320 or 13/20ths. Like I said, the whole number, you just move it to the side, leave it alone. Easy peasy. Okay, now in the answers, you know what? I should say it's just going to look like this. Okay? The only reason I put the word and there is just to let you know that it is separate. You have a whole number and a fraction. Okay? All right, we're up to letter E. All right, now we're going backwards. Now we're up to goal number 2. We're going from fraction. We're going from a fraction or a mixed number to decimal. Okay. there are two ways to do this. Okay? The first way is, and the book says it differently, but I'm just, whatever. I'm going to do it my way. Method number 1, what you're going to do, you're going to divide. And don't worry, I'm going to show you what it looks like. Divide numerator by denominator. Oof, okay. All right, we have letter E. Letter E. 3/5. The numerator is 3, and denominator is 5. We're going to divide this by this, this by this. So really, we're going to have this. And I'm going to color code it. The 3 becomes the dividend. The 5 becomes a divisor. And we're looking for the quotient, basically. All right. Now, we're going to use decimal points, and all right, to be ready for that. We have 3. We're trying to make groups of 5. We can't do it. I'm at a decimal point. And 1, 0. That means every hole that I just made, I'm going to cut up into 10 pieces. All right? So if I have 3 holes and each one's 10 pieces, I have 30 pieces. All right? And so 30 divided by 5 is what? Or really, the other way to look at it is, if you're making groups of 5 and you have 30, you can make 6 groups of 5 to get to 30, right? 5 times 6 gives you 30. Now, you know what? Just to use a placeholder here, you might want to put a 0 there to let you know, to remind you that there is no whole number. Okay? So, then why do I say that? Because really, you can't make groups of 5 out of 3, so it's 0. You go to the next value, right? I kind of skipped a step a little bit, but I'm assuming you know how to divide by now. So I kind of did skip a step. So then 3/5 is equal to 6/10. All right. There is another way. Method number 2. Now, I will never tell you on the quiz which method to use. Everyone's different. Everyone has their preferred way of doing things. I know, depending on the number, I might choose one way over another, but that comes with experience. So for now, I suggest you do both ways. Okay? Do it both ways so you know what works best for you. But here we go. Method number 2. Equivalent fractions. That's a little sloppy, but you get the idea. Okay. Okay, I'm just trying to think how to say it best without confusing you. All right, we have 3/5. There's our fraction. So we're trying to find another fraction and find a power of 10, right? That works. All right. So, power of 10, right? You have 10, 100. Now, I would say multiples of 10, but we're not talking about 20, 40, 60, although that could work too. It depends. All right? But leave that one for reserve just in case the other one doesn't work. All right? 10, 100, 1,000, etc., 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 right? Okay? Now, what I should have said, and I forgot to tell you this, but I'll cover it in the next lesson. Okay. I'll try 10. 3/5. Hey, look at that. Okay. It looks like I can scale up from 5 to 10 by a factor of 2. And whatever I do to the bottom, I do to the top. All right, I have 6/10. Well, shoot, the name says it all. Okay, 6/10. I know I'm going to have a 0, right? Because definitely that's just the way it's going to work, because I don't have a whole number. It's not a mixed number. So 0 point, or 0 and 6/10. Tenths is just one place value, right? 6/10. But here's the deal. You don't need to write the tenth, just erase it. And there you go. It's all the name, too. 0 and 6/10. 6/10, one place value. One place value. Just write the number that's above. That's your numerator. Okay? All right. I'm going to go ahead and do letter F. Okay. Same thing. I have 14 over 25. Oh, dear. Okay, now here's the deal. This is where you make a choice. What works best for you? I could try dividing again and go through all this business. I could do that. Or I can try and see if I can find equivalent fractions. 14/25, right? I'm going to try using a 10. Can I make groups of 25 out of 10? No. I mean, can I scale up from 25 to 10? No. What about 100? Yes, I can use 100. Okay. Okay. I can make 4 groups of 25 to get to 100. And like I said earlier, whatever you do to the bottom, you do to the top. 14 times 4, I believe, is 56. Now, 56 hundredths. It's in the name. 56 hundredths. All right. I definitely have a 0. Tenths, hundredths. I'm going to stop right there. Tenths, hundredths. 2 place values, hundredths. And you know what? If you ever forget, here's a quick trick. Count the zeros. The zeros will tell you how many lines to draw. Anyways. And there it is. Done. That is the answer. Okay. All right. Last one. And, by the way, there's always more than one way to do this. Okay? If you had, let's say, made it to 1,000, right? It would have been 25 times 40. This would have been 14 times 40. It would have been 560, and so forth. Then you would have added an extra 0. Technically, the answer is the same. It has the same value. But, you know what? Don't add more zeros than you have to. Just don't make it that habit. Okay. Letter G. 102, 250. All right. Whew. Again, I'm going to put no for this one just so I don't forget. I could try. I mean, it is doable. You could do this. This is fine. But no, it's just too much work. Let me look at the other option. I have 102, 250. Okay. All right. Now, I already know what I'm going to use, but I'm going to pretend that I don't know as much math as I do. I'm going to play with this. 250. If I can't simplify it to 100 or 10. By the way, eventually we'll get to big numbers where we have to simplify this to something smaller. To multiply. Sorry. You'll have to scale down to a power of 10. Okay, when we get to that problem, I'll show you. But for now, we're scaling up. I can't scale up to anything that I can think of. Let's try it out. I can't scale up to 10. Nope. 100? Nope. 1,000? Yes, I think I can do this. Now, if I'm not sure, but how many times? Okay, look. 25? And then 100. I know I can make 4 groups of 25 to get 100. You just add another 0, right? So 250 times 4, 1,000. Right? And 102 times 4, if you need... let me do the work, because some of you are still going to ask. 408 thousandths. Oh boy. Okay, look. Again, don't panic. There's no whole number, so it's definitely 0. 0 point. And you know what? Let's just go with what I said. Count the zeros. 1, 2, 3. Draw 3 lines. 1, 2, 3. And fill in the spaces with the numbers. 408 is the numerator, right? 408 is what you're going to write here. And you're done. Okay? Now, same thing. You're going to ask, what about if we have a whole number? What do we do if it's a whole number? Oh my goodness, what do we do? Blah, 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 blah. Same thing. Let me do another. I'm not making funny, by the way. It's just eventually, at some point, you got to stop saying, what do you do? What do you do? And just do it. Try it out. Make mistakes. If you make a mistake, no big deal. You erase it. And if you're a dodo head like me and use ink, I guess you can use whiteout or just cross it out. The point is, it doesn't mean that it ends. You can always do it again somehow. All right. So, let me ask that question. What if there is a whole number? What do you do next? Well, you know what? Surprisingly, it'll be the same thing you've been doing all along. Okay? So, 1 3/8. Whew, okay. You know how I said before? The whole number just takes a trip. It takes a trip again. You're going to have 1 and something. Don't even worry about the whole number. You just take the whole number to the side, leave it alone. Okay. Now here, 3/8, I can divide that easily. That's not such a big deal. I'm going to divide the numerator by the denominator. And by the way, I'm trying to think, can I make this into tens? No. Hundreds? No. Forget it. So I'm going to just have to go this way. Okay. Can I make groups of 8 out of 3? No. I'm at a decimal point and a 0. Okay. Now, how many groups of 8 can you make out of 30? Right? If you have, again, I'm not going to draw dots. If you imagine 30 dots, how many groups of 8 can you make out of 30? Let's just do times tables. 8 times 2 is 16. 8 times 3 is 24. Excuse me. 8 times 4 is 32. That's too much. We'll go back to the 3. 8 times 3 is 24. 30 minus 24, I'm going to subtract. I'm not going to do the regrouping. I can do this in my head. 30 minus 24. Literally, look at the big picture. Bring down the 0. All right. How many groups of 8 can I make out of 60? And it's just times tables, guys. 60 minus 56, 4. Okay, add another 0. How many groups of 8 can you make out of 40? 5. Okay. Oh, let me finish this. This is this. Right? And actually, you know what? Bear with me. You're going to see something in just a moment. Okay. You have 1 and 0.375, but you know what? That doesn't sound right. That doesn't look right. The 1 stays the same. So you can take out the 0. And you add a decimal point, because you're not going to write the word and, because you're saying, hey, I have 1 and 375 thousandths. Tenths, hundredths, thousandths. 3 zeros, 3 place values. 375 thousandths. And I think that's your answer. Let me check just to verify.